So good afternoon everyone, and today we would be seeing how to create your models, and not only create but deploy your models on web platforms. So at the end you can just give a link to any other person to access your models online. Okay, so your model, machine learning model, would be available for everyone to access. So one example that I told you was on SMS spam classifier. Okay, I have a link here, and once you go to this link, you would be able to access a model which can detect whether a text message that you receive is a spam or not. Okay, so pretty cool, right? And yesterday you learned naive bias. So today, while creating a spam classifier, you would be using naive bias theorem, right? So if some things went bouncer or some things you understood, some things you didn't, don't worry. We would be covering each and everything right now, and you will be seeing everything like happening in the code. So you would be better understanding it. So let's copy the link and just git clone. I'll cd into the folder. Okay, and with that I'll activate my virtual environment, everything just to activate my Jupyter notebook. So here, but before these things happen, I just want you guys to get understanding of a new library, and it's called Nltk. So Nltk stands for Natural Language Toolkit. So for deploying, like for creating machine learning models, we were using sklearn till now, right? So now we would be learning about a new library that is called as Nltk. So if you guys remember about yesterday, we discussed 5 things. Okay, we ended the session with 5 things, and that was how was our pipeline while we create our model, and that is nothing but our spam classifier model for SMS. Okay, so again, sorry for my bad handwriting, but here, first we get the data, we tokenize it. And tokenization means breaking down sentence, like breaking down your paragraphs into sentences and sentences into words. Okay, each and every word, and then removing stop words. So what were stop words? Does anyone remember? Okay, stop words like he, she, the word that don't like have a particular meaning, so that don't the words that shouldn't influence your model, so you need to remove those, and those are called stop words. Okay, so you need to remove those stop words, right? And then you stem, so run, ran, watch, watching, watch, all these would be converted into one particular tense. Okay, so watched, watching, watch, it will be converted into watch only. And then at the end you have your vocab, your bag of words or corpus. Okay, and on that you train. So now these 5 things we ended our yesterday's session with, and let's look at how these things work. So Nltk is another library. Okay, its full form is Natural Language Toolkit, and it's available on Python. In case you don't have Nltk, so pip install Nltk, right? Okay, sorry, Nltk. You can do this, and once you have Nltk, we are good to go. So, and like in sklearn, if you remember, we had many example data sets. So if you remember Boston house price prediction, it was a sample data set that we picked up from sklearn, right? So now in Nltk we have some sample dictionaries, like dictionary as in a collection of words. Okay, a bag of words, a corpus. So let's see how many are there. So nltk.corpus import, and do you have suggestions? See, so these many different types of it has dictionary like collection of words. So one of them is brown. So I'll import brown. Let's see what brown contains. So brown dot categories. Okay, sorry. Okay, I don't have Brown, so it gave me suggestion to download Brown first. So I'll download it before. Okay. And then I'll do brown.categories. See, so it has adventure category. It has these all different categories: romance, religion, science fiction, right? And in those, it has lots and lots of words. So brown dot words. So basically it's a corpus, and what is a corpus? It's a collection of words. So these many words this particular brown corpus has. Okay, it's a bag of words, and these are total words, and these words are into different kinds of categories. So for example, let's see. Okay, so let's see is equal to brown bro dot, I want to see sentences. Okay, and I want to see, can anyone give me a category? Come on, anyone, what you would like to read? It could be adventure, romance, science fiction, religion, news. Okay, the first one to write, that would be our category. You'll make sense of this. Okay, adventure. So we'll get adventure here. You'll get sense of this very quickly. Just hang on to it. Okay. And okay, so I'll just create a sentence. Uh, Data, let's say the first index. Okay, sorry, space. So he was well rid of her. Okay, let's try another one. So these are various different sentences that are incorporated in this particular brown corpus. And what is it? It's collection of words, it's collection of sentences. So what I used, I went into brown and I used sentences. Okay, so I want some sentences from the category adventure, right? And then I want to, so basically what it returns is, see, all the words, they are nothing but in a array. Okay, and from that array I want to convert a sentence. Okay, so what I did was, with space dot join, I am using a particular sentence. Okay, so basically what's happening is that each and these words, they are individual words, right? And individually they are like this array of words, and I want to create a sentence. So I joined each and every word by giving a space in them. So this is how you see it. So now you see a proper sentence, right? 19, let's say. Okay, so we have these different sentences in the category adventure, right? So now going back to what we were discussing. Okay, so we have our data. We have our sample data for now. We are just seeing what can happen in Nltk. So first thing, tokenization. Why? So we break down the sentences using tokenization. So from Nltk dot tokenize, I'll import send tokenizer. Okay, uh, tokenize, and also there is word tokenize, right? And so let's see, my sentence is this. So okay, I don't need this. This is my sentence. Okay, and I want to tokenize this sentence. So sentence, let's give us short form sends, and send tokenize this sentence. Okay, okay, so let me just download this first. Okay, now let's see, worked. So see, basically this sentence now is tokenized. So we had, let's say we had 2 to 3 sentences, right? When like see, here you can see, when in the late afternoon on the last day in June, he saw 2 people top the ridge to the south and walk towards the house. He went to work immediately and stored to his rifle. Right. So basically these are collection of sentences and separated by comma. So what it did was it separated out the sentences. Like let's see the length of sentences. Len, okay. So it's a one sentence only, right? It's a single sentence because you have only one full stop, right? Only one sentence here. Let's add one more sentence. So yesterday I finished Flash season 1, right? So I'll just say Barry Allen, okay, Allen is amazing. Okay, sentences happened too. Why? Because one sentence was finished and another one was there. So this could be considered like a para. If not, let's make it a para. Look. And okay. Better visibility, right? So this is a multi-line string. Now I made a multi-line string and now you can see two sentences. One is this, right? And I tokenized it. So now I have two sentences. Basically from one para, I gathered sentences. And now from this sentence, I want to, I want words out of these sentences. So let's see words equals to word tokenize sentence. Okay, now let's see the words. See. So now I have words out of these two sentences. Got till here? Right? So basically, if I had a long para, which could be in any SMS, so it could be like congratulations, you won a lottery or something like that. So it would be a para, okay, many collection of sentences. So first I extracted sentences from a particular para. Okay, so this could be two different sentences, right? So this was some words. Then I added Barry Allen is amazing. Okay. And let's say Flash is super fast. Right. Now how many sentences I have? I have 3. Let's print. Okay. So these are 3 different sentences I have and words. So these would be each and every word that I extracted out of those sentences. Right. So basically I tokenized, and by tokenize, I mean I got each and every word out of a particular collection of words. Right. And that could be a sentence, that could be a para, that could be anything. Now I want to remove stop words out of this. Okay. What is stop words? The words that I don't want, like that don't have any meaning and they shouldn't be while I train the data. So Nltk dot corpus, I'll import stop words. Okay, and SW would be my set of stop words dot words, and the words are from English. Okay, don't I have it? Okay, I don't have stop words, so I'll download it. So basically these are downloaded locally, right? So if you don't have, Nltk would give you an error and it will give you a solution as well, that basically you download these things. So I'll download is successful, and now I have the stop words. So let's see the stop words. See, above, after, again, against, all these words, these are considered as stop words by Nltk. And what is stop words? The words that don't have basically any meaning. Okay, so they shouldn't be existing in my particular sentence, right? So now let's remove them. So I'll create a function. Let's say stop word remove, right? It will take like set text and it will take stop words. Okay. And useful sentence would be okay, so words for word in particular text. So text would be a sentence. If word is not stop words. Okay. So basically I want words for words in text and it's not in stop words, right? So basically I'm just removing stop words and I'm just returning the useful words again. So let's see it in action. So useful words would be, what do we have? Stop word removed. I can give it a sentence. So what was it? It was called sentence, right? So sentence and SW. So what is my SW? My SW is my set of stop words, right? So if a particular word from this sentence, like a particular word does not belong in the stop words, okay? So does not belong in this set of stop words, you should use it, you should keep it, otherwise you shouldn't. So let's see. Okay. Wait. I'm sorry. Let me bring down this sentence here. Okay, these are my stop words. And dot split because I want to give proper words. Okay, now let's see. See. So when late afternoon, last day, June, saw two people. See, so some words are omitted here. Let's see len. Okay, len, useful words. 30. And what was length of original sentence? Len 46. So out of 46, all the different words, what were considered useful? Only 30. So 30 would be considered while training. Make sense? Okay. So there is another tokenizer and it's called regular expression tokenizer, right? So we use that while SMS classifier. So I'll show that one. Nltk dot to okay, sorry, tokenize import regex tokenizer. Okay, and then I'll tokenize equals to regex tokenizer, and let's say I want everything from A to Z and capital A to Z, right? Capital A to Z, and let's say at the rate 2 and dot, all the special symbols, right? And useful would again be my to basically this is nothing but another type of tokenizer. So there are lots and lots of tokenizers and you can explore some of them out by yourself. So tokenize and sentence. Okay, something wrong. Expected sigma bytes. Okay, I won't give special characters. Okay, sorry. I need a particular pattern, so it was okay. A pattern would be this. Grab the pattern. Okay, still not happening. So basically it expects a pattern. Okay, so I gave it one. Let's consider only all the words. Okay, wait a second. Tokenize sentence. Okay. Sorry. So it was basically not a sentence, but I gave it like array of sentence. Okay, so array of words. So that's why it's not working. So back to the track, and now let's print useful. See, so when in late afternoon on the last day, okay. So basically I tokenized the words again. So this was what my sentence looked like. I'll keep it here again. So my sentence was, when in the late afternoon on the last day in June, he saw two people talk on the ridge to the south and walk towards the home. He quit working immediately and strode to his rifle. Barry Allen is amazing. Flash is super fast. So basically I tokenized it. Okay. So instantly I have all the words, okay, useful, all the words from this particular sentence. So tokenization is done. We also saw stop word removal. Okay, so basically anything that is not in this SW, I want to remove it, right? Because they are unnecessary. So we saw stop word removal, we saw tokenization, right? So we had our data. Data was nothing but the sentence. We tokenized it. We also had stop word removal, right? Now stemming. So let's see stemming in action. And what it does is run, ran. It would be like it would be then changed into one particular tense, and that could be a run, that could be ran, that could be anything. Okay. So let's see stemming in action. So from Nltk dot stem import, we would be using port as stemmer. Okay, so ps equals to port stemmer, and let's stem, let's say laughing. So I got laugh. Okay, from laughing I got laugh. Let's say walking.
So
Okay,
basically, it returns the base word, whatever it will be in V3 form, V2 form. So what it does is it's tried to cut down the words. So there may be many words, walk, walk, walking. So it will return the base word, which is your verb. Okay, so here we passed on to the word walking, and it is written the V1 form of that is walk. Okay, so anything that is not useful for that, it will short down to the original word. Okay, so that's the main use of quota streamer.
so
Okay, go
basically
on. Atham.
you are creating your dictionary. You don't want like unnecessary words, right? So basically that's what we are dealing with. So like I don't want walking also, walk also, run, running, run. So I don't want to create another, like I don't want to give them another indexes for each and every word. Basically they have the same meaning, so why do I give another words for them, right? Okay, 1 second. Okay, let's consider this, and let's take another example too. So where did I have it? Right. Uh, sentences. Let's take 20. Okay, let's use this too. So now I would have collection of words like this. Okay, it could be like this, right? And then what I do is I count vectorize them. Now what is count vectorization? So ARN dot feature extraction and text. I want to import count vectorizer. Okay, and CV would be my count vectorizer. Okay, and my vectorized text, let's say, would be CV dot fit transform. If this is not making sense, just give me a minute. I'll be explaining this when you'll see these things in actions. Okay, so VC dot vocabulary. Do I have it yet? No. Okay, sorry. Uh, okay, so VC I have to convert first to, I guess, array. Okay, let's print VC. Okay, so how many sentences I have? This one, Okay, let's make it more. So I'll just pick this from here, comma, give it another one. Sorry. Right. So now I have a particular collection of sentences, three different sentences. See, one, okay, two, and three. And now I want to create a dictionary out of it. So see, what is this? 0 to 1, 1, something, something, right? I have three different types of, like I have these sentences converted into numbers. Now, how did I do that? How this thing happened? So let's see our vocab. Uh, see. So what happened when was given index 46, in was given 16, late was given 22. So basically what I have been telling you, these all different words, they were given indexes of nothing but letters, right? Like numbers. So these words were converted into numbers. So that's what you have, right? All the useful words, okay, they were given a particular index, and then in the first sentence, so let's say when, in the late afternoon and all, okay, it was converted to like numbers. But what more happened with it? We used count vectorizer. So the number of times this index one like this number on index 0, so index 0 is afternoon, so number of time afternoon occurred in the first sentence. Okay, so it could be one. See, afternoon only occurred one time. So second would be index 1. So index 1, where do I have it? So Alan, see, Alan was given index 1. So in the first sentence, do I have Alan anywhere? So this is my first sentence. Do I have Alan anywhere? No. So that's why 0. And now I have to like a proper number of sentence. Let's see. We like okay, sorry. So we see. Uh, I messed up. Wait. Okay. So basically now you have same number of features. So while training, you need same number of features every time, right? You like each and every sentence. It couldn't be like they have different number of words. Okay, actually they have different number of words, but basically you need them to be of same number, like same dimension. So all the other words, they are replaced by 0. So in count vectorization, what actually happens is that you have a bag of words created. Okay, so when you do fit transform, you get a bag of words created. See, so this is basically your bag of words. These are all the words you get, and what you do is you see how many times those occurred, right? So your number of features would be nothing but total number of words you have. Okay, so total number of words in your this bag of word, that would be what you have, like total number of features. So for image, we had like just like if you remember, we did classification of numbers from 0 to 9. Okay, so from 0 to 9 we had numbers and we did classification for them. So if it's the number 0, 1, 2, 3, 4, something, something like that. Okay, and then we had total 28 by 28, right? 784 features. So we had 784 features. So you need fixed number of features to work on. So now what you did was, when you did count vectorization, so number of words in your vocabulary, that would be your total number of features, and they are replaced by the sentence. Okay, so they are replaced by sentence, and their count, so the total number of occurrences, they are replaced by the words. So now you have a particular numeric data to work with, and then you can apply knife bayes and all the other stuff. uh, so let's say working with Nltk. Don't worry if you didn't get it here. So let's directly see our spam classifier. Okay, let's see our spam classifier right now. So in case you don't have stop words or any other, you can just download it using nltk.download, right? Importing our packages and our data. So I had a training data and it had messages in the first index, right? So messages I had, and I had the label, whether the message is ham, whether the message is spam, right? Then in what I did was I converted it to numpy first of all, and then I separated my x and y. So what would be my x? Everything that is the first column x. Okay, so the first column only, I have only two columns. What would be the message and other would be ham or spam, right? So I considered the first, that is message text. So I took the text, that is the first column, and second would be its labels. So labels, I took each and every row. Okay, each and every row, and only the for index one, that would be the second column. Second column would be ham or spam, right? So I have x and y. Then I just imported my tokenizer, my stop word, okay, so the dictionary of my stop words and my stemmer, and I created a function to stem particular sentences. So basically what I did was, if I pass a sentence through to this particular function, what it will do? First, it will convert a particular function into like it's lower. Okay, so basically if there are any capitals, so everything would be converted into lower. Then you tokenize them. So you have a sentence, you separate out word by word. And which tokenizer we are using? We are using regular expression tokenizer, right? There were others as well. And then after we remove stop words, right? So for words which are not in the stop words, what are our stop words? Stop words we got from nltk.corpus. So it contained all the stop words possible, right? Let's see stop words if you want. So this above, about. So if any sentence contain these words, they would be omitted. Rest all would be returned in removed stop words, right? And then we stem them. So we tokenized, we removed stop words, we stemmed. And what was stemming again? So converting each and everything to basically running to particular run, okay, to one form, right? So this was for a particular sentence. Then I returned basically the sentence, right? That. So let's consider an example. And here I cleaned it. So basically, let's give you an example. I'll take the example from before. So here I had a sentence. Okay, I had this sentence, and what I'll do is I'll stem the sentence. Let's say like a equals to, sorry, stemming. I'll stem the sentence. So basically each and everything is happening in there. Okay, it's not only stemming, but it's tokenizing, stop word removal, and stemming. And now let's return the sentence. So see, so this everything, it was converted into what? Late afternoon, last day, June saw two people, top, rich, small. See, it's not this sentence. What happened? Three steps happened, right? In this particular function. What was it? First, I had the sentence, I converted into lower. So basically this capital W was converted into smaller. Okay. So the tenses were lowered. Next, what I did, I tokenized. So I extracted each and every word, and using what? Using regular expression tokenizer. After that, I basically removed stop words and I cleaned the sentences. I stemmed them and I returned them. So this was for a particular sentence. What happens for a whole like document or collection of sentences? So for D, like this is a plain array, and for doc in particular document. Okay, so for one particular sentence in all the document, I'll just get the document, and that's what I did, and I got a clean X. And then basically I did count vectorization, right? So now how like total number of words I had in particular dictionary, I replaced them in those like these form. Okay, so for one particular sentence I converted into numbers. So now these could be easily trained. So now I have my data. Let's see if you want. See, I have matrix, and if you want to see its shape, okay, sorry, it's a tuple. Then basically we did the train test split, and we fit our multinomial naive Bayes, and hence we got our score. So basically each and every model, like you can create models, right? You have different models. So now we would be seeing about how to deploy them. Once you have your model, you need to deploy them, right? So basically now this model knows how to convert, like how to predict a particular text is spam or not. Okay, it could be a spam, it could be ham, whatever. So now I have model. Now I want to export it. I want to export whatever it has learned. So what I'll do is I have a library called joblib, and what it does is it dumps my count vectorizer and my model. So basically, see what is this count vectorizer? It has all my, like my dictionary. It has my collection of words. Okay, so with fit transform, I created a dictionary which contained all my words, right? And using that I fit it. So I need a count vectorizer and my model to be exported. So basically I exported both of those. So that's what basically is happening. And then for again testing purposes, so I had another test data. Okay, the same thing, cleaning I did here. So now I won't be doing fit transform. So fit will fit the particular text and then transform. What will it do? It will create dictionary, but I don't want to create the dictionary again. I don't want it to learn again. So I'll do only transform here. And once I have, so basically I can predict for a test data whether it's a spam or ham. Okay, so this quiz was looking ham, and then okay, these are all hams. So basically that's what happened, and we got the accuracy of 98%. So just remember that naive Bayes works very good with classifying like natural language. Okay, so this is what we did, and we exported our models into .pkl. .pkl is a pickle. Okay, it's called pickle, and it's an extension to save whatever you learned in a particular model, right? So this is how we created a spam classifier. So it is all about creating a model. Basically now what we did was we created a model. It could be any model. So this was a spam classifier. Let's suppose any model that we created before. So it could be house price prediction in Boston, right? We did it before. So it could be that model as well. So that model is, also we can export. So we will import joblib and we will do joblib.dump. We will use the model and we'll dump the model. So that's it. So now whatever the model has learned, I can export it using this .pkl extension using joblib. So that's basically not now what we did. And then what we want to do, we want to use the model further on. Okay, but before that, you need to know what happens when we work in like when you type www.google.com. So some basics you need to know, like everyone need to know. And does anyone have any like particular knowledge of what happens when you type www.google.com? How does it know which thing to load and what to do? Can I get some answers? So now we are like moving towards deployment. अभी हम थोड़ा deployment देख लेंगे. हमने मॉडल क्रिएट किया था बेसिकली एक स्पैम क्लासिफायर. अब हम लोग डिप्लॉयमेंट की तरफ जाएंगे. So anyone wants to weigh in? Why do you like what happens when you type www.google.com? What is it, right? And then what protocols power the whole internet? You should have known something called as HTTP, right? So what is that HTTP and everything? Yeah, Daniel, that's right. DNS, exactly. Like you can say, and this code 500. So what does this particular page mean? Okay, and whenever you're doing payments or when you filled a form, you get this. So why should you avoid pressing back when you're making payments? So these are some kind of basic things you might be looking into. So how the internet works, right? So whenever you type www.google.com or any other site, is it on particular that name? It's never on the name. There is a particular server. Everything is based with the IP address. Okay, so it could be 192.168.0.1. So this is an IP address where I can configure my Wi-Fi. So basically each and everything is on a IP address. So for example, I'll do dig www.google.com. Okay, I have something. What is it? It's address. And I have this port. Okay, so I have this IP address. Let's see what happens when I type this IP address instead of the name. Google loaded. So basically what these names are, they are nothing but aliases. Alias like calling simpler name. So just imagine if you have to go to google.com, would you be typing this particular address? When I have to surf a particular website, it could be any website. Okay. So would I be using this address? Okay, would I be typing such addresses to go to? No, right? I want some easy names that I could speak. So google.com. So what basically happens is that we give a alias. Okay, we give it a nickname for a particular IP address. So this particular IP address, you give a nickname that is google.com. Another thing. So to access this thing, what happens? Okay, you type www.google.com or you give this particular port number, but what happens? So let's inspect a page and we'll go to network and let's go to a website. So let's see. Okay, these all different things are happening in background. I have all. So let's see this. I have these status codes like 200, 404, 300, right? So what are these different things? Let's see this. So request method was get. This is what I requested for. That is IEEE.CSSBC.org, right? And where is it located? Where is the server? So I have everything right here. Okay. So the server is from with Cloudflare and I should be having address and everything here. So this is what I requested. So see, it knows what device I am on and it should have everything like where the particular see. So this is the remote address, right? So this is the address where the site is particularly deployed and 443 is the port number. So whenever you type a particular address, what happens? So when I'll type a new address, what happens is that a get request is sent to the particular name. So I'll type a name here. Okay, let's see IEEE.CSSBC.org. But what happens when you type this name? So basically a request is called. So first thing what will happen? I sent okay, take me to IEEE.CSSBC.org. So what my browser will do, it will just ask, okay, so where is this IEEE.CSSBC.org? I don't know its location. Can anyone tell me its location? So basically that's when this DNS called as domain name server that comes in handy. Okay. So basically then server looks for his IP address. So I have its IP address here. And once I have the IP address, what I do is, okay, so I got the IP address. I know from where I have to fetch the files. So then I fetch the files, then the website is shown. So this was a get request. Similarly, when you are posting, like when you are posting a form or something, so there are different types of requests. So this was a get request, right? There could be another request, right? There could be a post request. So these were get requests because you just got the particular website. When you are filling the form, it could be a post request or it could be put request. So there are different types of request. And the basic thing that happens is that a get request. So whenever, just keep this in mind. So whenever you type any domain, so it could be, let's say facebook.com. So my site asked, so like my Chrome asked, okay, where is this facebook.com? It will ask its DNS. Okay. So it asked it DNS, okay, show me where is facebook.com. It got its IP address. It went to that IP address and a get request was made. So get that particular website. That was the request that we did. Right. So yahan tak chamka. If you have any queries, please ask. And I'll open. Yes, good. Okay. So for machine learning, what happens is that you have exported your files, okay, in this model.pkl, and this was our count vectorizer. Then what you do is we deploy it using Flask, okay. And what is Flask? Flask is basically a framework in Python, okay. So when you deploy in a Flask, like when you deploy using Flask, what you do is you create a Python script and you initialize Flask, right? And Flask is kind of a backend. So whenever you want to create a particular website, what you need? You need a front end, you need back end, right? And you need database. So there is front end, there is back end, there is database. Front end, it's handled using HTTP, CSS, JavaScript, right? Backend could be used using Python, Java, JavaScript. Anyone web developer here? Getting what I'm saying? Basically in web development, there are three things you need, okay? Back end, front end, illustration if you have. Okay, see, user, he's in front end, he's saying, but in back end, it could be any other different story, right? Another example is of a, let's say a restaurant. So restaurant, you are a user, you went to a restaurant, ठीक है? हम restaurant में खाना खाने गए. You are a customer, you are sitting on the dining table. And front end, so front end would be whatever you see in a particular restaurant, okay? So in restaurant, whatever you see, it could be the front end. So it could be the chairs, the table, the, okay. Then you have backend. What backend does is it takes your request. So basically when you send a get request, so I do www.google.com, okay. And what happens is that this request is then went like this request goes to a backend, and that backend will be like, okay, so I got a get request and I should respond it by giving the HTML file for google.com, right? So if you have a HTML file, what you do is I request www.google.com. This request goes into backend. Backend handles whatever to show or not. Okay. So backend will see, okay, we got a get request. So what I have to do with get request, I have to return google.html to the user. So that's how you handle things in backend. So basically Flask is used for backend, right? And this was the backend of Spamia. So here was pre-processing. So first thing first, you import Flask. Okay, so from Flask you import Flask requests, JSONify and render template, right? And you need a particular way of storing the files. So basically in a root folder. So for I have to create a new Flask, what I do is, let's say app. So I have to create a new app. Okay, what I'll do is I'll have a new folder named templates. And in templates, what I'll have all the HTML files, right? So templates, see, templates, I'll have HTML file. Let's open the HTML file. So this is the HTML file, right? The body, the HTML file. This is what I have. Okay, this would be stored in templates. Then static would contain my CSS. CSS would give it the color, the texture, the everything. Okay. So for like to create a new web app for your model, what you need? You need a new folder. In that you have two things, that is templates. Templates contain your HTML files. Okay, didn't I paste it? Copy. Okay, template will have your HTML file, and static, it will have your CSS. Okay, so CSS for your template. So this is what you will have in these two folders, and then you will have an app.py. Okay, it could be app.py, it could be application.py, it could be anything. So this is how a basic Flask apps directory would look like, right? And then this in this app.py you configure your file. So basically first what you do, you import your Flask, okay, and all the other libraries you need. So this was for particularly deploying Spamia. So you can ignore these parts, but basically for Flask, so first you import Flask, right? You import JSONify and render template. So render templates return it. So then you have app.root. Okay, this is the main path. And in that, if I have post request or a get request, so get request is what you get every time. Okay, get request is what you get every time you call any app. So it could be spamia.heroku. Okay, I didn't have it here. So basically, whenever you request for a particular app, a get request is passed, right? So if request.method is, let's suppose, get, then what I'll do, then I'll do return render template index.js. And where this index.js should be located, it should be located in a templates folder. So in templates folder, see, I have this index. What I have, it's just a title spamia, and it's linked with my CSS. Okay. So this is my style sheet URL for, and it gives me the URL for particular style sheet. Then in the body, I have nothing but just a single form with only one input, and that would be a text. That would be a message, and a submit button to submit that message. And on submit, what I want to do, I want to I want to send a post request. Okay. So when I am submitting a form, a post request is sent. So I need to submit a post request in the URL for home. So what is this URL for home? So again, app.py. So this is the URL for home. Okay, so this is the home. Okay, my function home. Where is it? It's in the app root. Okay, the main root. So this is the main root. And here, if I get a post request or a get request, it could accept both. And if the request.method is get, just return this index.html. Index.html is situated in templates, and static will have CSS. Okay, so HTML, CSS are for my front end, my backend is Flask. So basically what you have to do, then you have to configure for different requests. So for get request, what it will do, it will just simply render template is index.html. So it will just return this index.html, which you see basically. So spamia, whenever it will load, because Heroku seems to have been sleeping these websites if they are not used. Right. So if the request.method is get, okay, so basically I didn't write it because I have basically defined it outside this if statement. Okay, so if the request.method is not post, then this thing will happen. If the request.method is post, these things will be executed. Right. So for this particular app route, only post and get would be accepted. So for post method, these things would execute, and for not post, this thing would be executed. And not post would be one and only get, because I'm just accepting two methods, that is post and get. So for get request, I'm just returning this index.html. Okay. So this index.html is returned when I do a get request on this website. Right. So now, like basically whenever you load first any website, a get request is called in the particular root. Okay, that is the home directory, and I get a HTML CSS here. Right. Now if request.method is post, and how this post method would be sent, it would be sent whenever I fill this form. So in HTML, I have this form, and on submitting the particular form, a post request would be sent for the URL of home. So a post request would be sent if I submit this form. Okay, so you won a let's say lottery of 5,000 in your bank. Okay, spam, got it right. So basically what happened was a post request was sent then. Okay, so the post request was sent, and then what happened, text was extracted from the request.form message. Okay, so message was the name of the input. Right, so I got the input in my backend after post request, so request.form, and from that form I got the message. Then I use the final message equals to text. Okay, so the final message were and then I passed this final message into this prepare function. And what the prepare function did was it returned me an array of stemming, and this stemming function was defined in the like IPNB also. What we had, we took a sentence, we tokenized it, we removed stop words, we stemmed it, we cleaned it, and we returned it. So now I have a clean sentence, and then I can do model.predict. Okay, so I predicted, and once I have the prediction, then I again return for the particular post request. I return again render template index.html with a prediction text that the message was, and the this prediction. So prediction is nothing but my variable which contain the prediction for the particular message, whether it's a spam or not. So I returned it here. You can see these codes on the GitHub repository. You can take some time to understand it by yourself. It's in here. Okay, spammy I have here. So you have everything in here. So you can check it out. So basically then what you have an app. Okay, so this is how basically your normal Flask would look like. Your Flask app would look like. Okay. This is how your Flask app would look like. And then for particularly loading the models, you'll get the models here. Okay, so these models here. I can do cd in and then python app.py. Okay, conda activate. Okay, and then I will run this app.py. So I have hosted this session locally here. See. So if we want to see it with inspecting as well, see. So for this particular route, this particular site I went, I got these all written. What was sent? A GET request was sent. A GET request was handled using which method? Okay, so if the request.method is post, then this thing is handled. If not post, the only other way we have is get. So if get request is there, we render template index.html. So index was rendered. And then if you give a particular message, so the like let's say you won a you won a lottery of worth 5,000 in your bank. See, so now request changed. It was a post request which was sent. So I have to handle this post request is backend as well. So I handled it in backend. So if request.method is post, then I did my prediction and everything, and I returned the template again. So here I have the output with the message that the message is spam. Okay, so the message is, and with that I returned prediction. The prediction was model.predict, right? So this was for particular text. So any other type of model you can deploy. Even for numbers, you don't have to worry about anything. So you don't have to prepare about text processing, etc., etc. Right? What you can do is you can directly load the model. So how you can load the model? Joblib.load open, and you can just open your model.pkl and read binary. So you have the model right like there as it is. Okay, and once you have the model, you can just do model.predict and you can return whatever you have the predictions. So that's how deployment works. And once you have that, then you can just try first using a local session by using just Python and space your app.py, and you can run it. So you can see basically this is nothing but the backend. So whatever request you have in the backend, it will be visible here. I reloaded, it should get appended. See, so everything happens here. You can see whatever is happening in the backend, whatever requests, etc. you have. So that's basically how Flask works. server. And then once you have everything created, okay, so in Spamia, like I have everything created, so then I want to deploy it. So for deployment, I selected for deployment, I selected Heroku. So you can go to Heroku, and Heroku, then you can just create new, you can create new app, let's say spam classifier, right? And it should be globally unique. So APK. So just to make it globally unique, you can give whatever name you want to. You can select GitHub. Okay, you can push your code in a new repository of GitHub. It should contain all the files you want, and the files would be your app. Okay, and these two folders, that would be the static and template. Template would contain index, static would contain your CSS and your models, and app.py. So readme is nothing, like readme is just for instructions, so you don't need readme. This proc file is basically a instruction for Heroku. This proc file will contain your startup request, that would be, it's a web gunicorn app, and you need to launch app. So basically with this green unicorn, it is again a core of Flask. Okay, so it runs on Heroku. So for Heroku, this is a Heroku specific file, that is proc file, and you will write this web gunicorn green unicorn app. Okay, and so that's how uh, it will be deployed on Heroku, and that's everything you will need. Okay, so let's for example take this to in the app. Okay, I'll need a proc file, and I'll need requirements.txt, so it will contain each and every requirement of whatever modules you require. So you require gunicorn, you need scikit-learn, numpy, Nltk, and Flask, right? And once you have everything it requires, you can just basically upload it on GitHub, and you can just select the repository here, and basically your Flask app would be deployed on Heroku. So any other platform you can select. So if you are selecting other platforms, then of course you don't need this proc file. Okay, it could be any other. So for Azure and all the other file, like all the other services, you don't need this proc file, right? So this is just the basic introduction of how you particularly get your model created and deployed. So if you have any queries, please feel free to ask. And this is what we had for today. So what I'll request is just go to this GitHub repository first, and you can just see this code here. Okay, what is pickle file? Pickle is basically a binary file in which you store whatever your model has learned. Okay, so we create machine learning models, right? But you need to store whatever the machine learning like whatever the machine learning model has learned, right? So whatever you have learned in the machine learning model, you need to export it. And one of the export it's like a PDF, but for your models. Okay, so this would be the basic understanding. So it just exports whatever you have in binary, and .pkl is nothing but the extension. How to import in Python the Jupyter class? Sorry, I didn't get you, Daniel. What are you trying to ask? In Python, I didn't import Jupyter class. Daniel, can you be more specific, or do we have any other questions? Not only Daniel, but anyone? Basically, these things you get when you try on your own. You don't get it when another one is speaking, and okay, so it doesn't happen like that. You need to try these things by yourself. You need to try creating a model and exporting by yourself. And once you do that, then only you get how to do this thing. So thank you so much for joining in. We will be ending the session today.